April 18, 1944, Messerschmitt Factory, Augsburg, Germany. Chief Engineer Willy Messerschmitt stood on the factory tarmac, his hands clasped behind his back as a Me-264 America bomber taxied past. The morning air carried the sharp smell of aviation fuel and hot metal. Sunlight glinted off the bomber's aluminum skin, catching on the two Junkers Jumo 004 jet engines bolted to its wings. Each engine's intake cone a sleek silver cone, a stark contrast to the four radial piston engines that had powered the original Me-264. Messerschmitt's gaze fixed on the pilot, Hauptmann Erich Warsitz, who gave a thumbs up from the cockpit before advancing the throttle. The piston engines roared to life first, a deep, throaty rumble that shook the tarmac. Then the jet spooled up, adding a high-pitched whine that cut through the air. The bomber lurched forward, gaining speed as it rolled down the 3,000-foot runway. At 120 miles per hour, Warsitz pulled back on the control stick. The Me-264 lifted off smoothly, its wings leveling out as it climbed to 10,000 feet. It banked left, circling the factory once before heading toward the Bavarian countryside. Below, workers and engineers cheered, their hats raised in the air. Messerschmitt's jaw tightened. This jet-powered bomber could fly faster than any Allied fighter, carry a 4,000-pound bomb to New York, and return, all without refueling. It could shatter America's industrial heartland, force the Allies to divert resources from Europe, and maybe even turn the tide of the war. But he knew time was running out. The Allies' bombing campaigns were intensifying. If the Me-264 jet variant wasn't ready for mass deployment by winter, it would be too late to matter. The Me-264 jet project was not born from ambition alone. It was a product of Germany's deepening desperation in 1943. By then, the Luftwaffe's bomber fleet was a shadow of its former self. The Heinkel He-111, a mainstay of the 1940 Blitz, could only reach 230 miles per hour and carry a 2,200-pound bomb 1,200 miles. The Junkers Ju-88, faster at 280 miles per hour, still lacked the range to strike beyond Britain or the Western Soviet Union. Allied fighters, particularly the American P-51 Mustang and British Spitfire Mk-9, outclassed German bombers in speed and altitude. In 1943 alone, the Luftwaffe lost 3,500 bombers to enemy fire, a rate it could not sustain. Hitler, furious at the Allied bombing raids on Berlin and Hamburg, demanded a strategic game-changer, a bomber that could hit the United States, the source of Allied war production. The original Me-264, a four-engine piston-powered bomber, had first flown in December 1942. It had impressed the Wehrmacht with its 6,000-mile range, enough to reach New York from a base in western France, but its 250 miles per hour top speed made it an easy target for P-51s, which would overtake it by 187 miles per hour. Messerschmitt, who had built his career on innovative aircraft like the Bf-109 fighter, saw a solution in jet propulsion, replaced two of the Me-264's piston engines with jet engines, he argued, and the bomber would outrun any Allied defense. It was a radical idea. No nation had ever put a jet-powered strategic bomber into combat, but it was Germany's last, best hope for a long-range strike capability. The technical groundwork for jet-powered flight in Germany had been laid decades earlier, but it was not until the 1930s that it moved beyond theory. In 1937, Hans von Ohain, a 24-year-old physics student at the University of Göttingen, developed a working jet engine using an axial flow design, air compressed by rotating blades, mixed with fuel ignited and expelled to generate thrust. His first prototype, The Heinkel III produced 550 pounds of thrust. With support from Heinkel Aircraft, von Ohain installed the engine in a small experimental aircraft, the He-178. On August 27, 1939, test pilot Eric Warsitz, who would later fly the Me-264 jet variant, took the He-178 into the air for the first time, making it the world's first jet-powered aircraft. The flight lasted just 8 minutes, but it proved jet propulsion was viable. However, the Luftwaffe's high command dismissed the jet as a scientific curiosity. Field Marshal Hermann Göring, head of the Luftwaffe, famously declared, "The future of aviation is in piston engines. Jets are for toy makers." This dismissal delayed jet development for 2 critical years. By 1941, with Allied fighters gaining the upper hand, the Luftwaffe finally reversed course. It commissioned Junkers to develop a production-ready jet engine, the Jumo 004, and Messerschmitt to design a jet fighter, the Me-262. By 1943, the Jumo 004 was ready, an axial flow engine that produced 1,980 pounds of thrust, weighed 1,540 pounds, and could run for 50 hours before needing overhaul. Messerschmitt immediately saw its potential for the Me-264. If 2 Jumo 004s could replace the bomber's inner pair of piston engines, the Me-264's speed would jump from 250 miles per hour to over 350 miles per hour, fast enough to outrun every Allied fighter in service. Modifying the Me-264 to accept jet engines was a Herculean engineering challenge. The original Me-264 was a large aircraft, 77 feet long, with a 110-foot wingspan and a maximum takeoff weight of 110,000 pounds. It relied on 4 BMW 801 radial piston engines, each producing 1,700 horsepower, to carry its 2,500 gallons of fuel and 6,600-pound bomb load. Swapping 2 of these engines for Jumo 004 jets required rethinking nearly every system. First, there was the issue of weight and balance. The Jumo 004 weighed 1,540 pounds, 200 pounds more than the BMW 801. Adding 2 jets increased the bomber's weight by 400 pounds, which threatened to throw off its center of gravity. Messerschmitt's team, led by senior engineer Rudolf Seiler, solved this by removing 600 pounds of armor from the bomber's belly, a controversial choice, but one justified by the jet speed, which will reduce exposure to anti-aircraft fire, and replacing the wooden tail section with lightweight aluminum, cutting another 300 pounds. They also added 200 pounds of lead ballast to the nose, restoring the bomber's balance. The result was a net weight reduction of 300 pounds, which helped offset the jet's extra heft. Second, fuel consumption was a crisis. Jets burned fuel at a rate that shocked even experienced engineers. The Jumo 004 consumed 150 gallons of jet fuel per hour, nearly double the 80 gallons per hour used by the BMW 801 piston engine. The original Me-264's internal fuel tanks, which held 2,500 gallons, would only power the jet variant for 12 hours of flight, cutting its range from 6,000 miles to 4,300 miles, too short to reach New York. Seiler's team expanded the internal tanks by 700 gallons, increasing capacity to 3,200 gallons. They also added 4 external fuel tanks, each holding 500 gallons, mounted under the wings. These external tanks would be jettisoned once the bomber reached combat altitude, reducing drag and weight for the attack run. With the expanded tanks, the Me-264 jet variant's range climbed back to 5,800 miles, just enough to reach New York from France and return, provided the pilot conserved fuel by using the piston engines for cruising and the jets only for speed during the attack and escape. Third, cooling the jets was a critical problem. The WWII-004's turbine reached temperatures of 1,800 degrees Fahrenheit during operation, and without proper cooling, it would seize up in minutes. The original Me-264's wing design had no provisions for the large air intakes the jets needed. Seiler's team redesigned the wings, adding 3-foot wide air intakes along the leading edges, just outbore the piston engines. These intakes directed cold air to the jet's turbines, while exhaust flaps on the wing trailing edges allowed hot air to escape. They also lined the engine nacelles with asbestos insulation to protect the wing's aluminum structure from heat damage. Early tests revealed the intakes were too small. Temperatures still spiked above safe levels, so the team widened them to 4 feet, increasing airflow by 30%. The fix worked. In subsequent tests, the jets ran for 45 minutes without overheating. Fourth, the bomber's electrical system needed upgrading. The WWII-004 required 24 volts of power to start its fuel pumps and ignition systems, while Me-264's existing system provided only 12 volts. The team installed a second 12-volt battery and a voltage converter, allowing the jets to draw the power they needed. They also added a backup generator, critical for long-range flights where a single electrical failure could disable the jets. The first prototype of the Me-264 jet variant, codenamed Fliegender Panzer Flying Tank, for its combination of speed and payload, rolled off the assembly line in March 1944. It retained the original Me-264's boxy fuselage and high wings, but the jet engines gave it a more aggressive profile. The cockpit was modified to include a FUG 218 Neptune radar display, borrowed from the Ju-88 night fighter, which allowed the pilot and navigator to detect enemy fighters up to 25 miles away, even in darkness or cloud cover. The bomb bay was reinforced with steel plates to carry a single 4,000-pound hot-drop bomb, high-pressure bomb, a new design that could penetrate 10 feet of concrete, ideal for destroying factory foundations, or 6 500-pound incendiary bombs, effective against urban targets. The crew of 6, pilot, co-pilot, navigator, bombardier, radio operator, and tail gunner, sat in a pressurized compartment in the forward fuselage, protected by 1-inch steel armor plating around the cockpit and 1/2-inch armor around the rest of the compartment. The tail gunner manned a remote-controlled 20mm MG-151 cannon, guided by a periscope and linked to the Neptune radar, allowing him to engage fighters even when visibility was 0. The first test flight, on April 18, 1944, was a tense affair. Wartime, who had flown the He-178's first flight 5 years earlier, climbed into the cockpit at dawn. The ground crew spent 90 minutes checking the jet's fuel lines, cooling systems, and electrical connections. At 7:30 a.m., Wartime advanced the throttle. The piston engines roared to life first. Then the jets spooled up, their whine rising to a high pitch. The bomber rolled down the runway, its landing gear bouncing slightly on the uneven tarmac. At 120 miles per hour, Wartime pulled back on the stick. The Me-264 lifted off, climbing slowly to 5,000 feet. Wartime tested the controls, banking left and right before engaging the jets fully. The bomber surged forward, accelerating to 360 miles per hour, 110 miles per hour faster than the original piston-powered model. For 25 minutes, Wartime flew over the Bavarian countryside, testing the jet's response at different altitudes. Then, at 10,000 feet, The Wright jet's temperature gauge spiked to 2,200 degrees Fahrenheit above the safe limit. Wartime shut down the Wright jet and reduced power to the left, relying on the two-piston engines to maintain altitude. He returned to the factory, landing smoothly, but the right wing dipped slightly as he touched down. The landing gear on that side collapsed under the uneven weight, damaging the wing's leading edge. The team inspected the jet and found the cooling intake had become clogged with a bird's nest, restricting airflow. They cleared the intake and added a mesh screen to prevent future blockages. Despite the mishap, Messerschmitt was encouraged. "The core concept works," he told Seiler. "We just need to fix the sheet jet." The second test flight, on May 5, 1944, was flawless. The team had replaced the damaged wing, added mesh screens to the air intakes, and adjusted the jet's fuel mixture to reduce temperatures. Wartime took off at 8 a.m., climbing to 25,000 feet, higher than most Allied fighters could reach. He engaged both jets, accelerating to 380 miles per hour, and maintained that speed for 45 minutes. The temperature gauges stayed steady at 1,750 degrees Fahrenheit, well within safe limits. He performed a series of turns and dives, testing the bomber's maneuverability. Though it was still slow to turn, its speed more than made up for it. He then shut down the jets and cruised back to the factory on the piston engines, conserving fuel. The landing was smooth, with no gear failures. When Wartime climbed out of the cockpit, he was grinning. "It handles like a dream," he said. "Faster than any fighter I've ever flown." Combat trials began in June 1944 at a secret airfield in southern Bavaria, codenamed Fliegerhorst 17. The Luftwaffe provided a captured P-51 Mustang, flown by a German test pilot with combat experience, to simulate Allied interception. The first trial pitted the Me-264 jet variant against the P-51 in a chase scenario. The Me-264 took off first, climbing to 25,000 feet and engaging its jets to reach 370 miles per hour. The P-51 took off 10 minutes later, climbing as fast as it could. At 20,000 feet, the P-51 reached its top speed of 437 miles per hour, faster than the Me-264, but it could not sustain that speed for long. The P-51 closed within 5 miles of the bomber, but the Me-264's tail gunner, using the Neptune radar, detected it and opened fire with the 20mm cannon. A single burst struck the P-51's engine, forcing it to land. The Me-264 continued to its target, a mock factory 200 miles away, dropped its bomb load, and returned to base. The trial was a success. The bomber had outrun the P-51's, sustained speed, and defended itself effectively. The second trial tested the Me-264's range. The bomber took off with a full fuel load and flew a 3,000-mile round trip to northern Norway and back. The pilot used the piston engines for cruising, switching to jets only when passing over a simulated enemy airfield to avoid interception. Fuel consumption was higher than expected, 1,800 gallons for the trip, compared to projected 1,500, but the bomber still had 1,400 gallons left upon return, enough for another 800 miles. The navigator reported that the Neptune radar worked perfectly, detecting 2 simulated enemy fighters at 20 miles and allowing the pilot to divert around them. The third trial tested bombing accuracy. The Me-264 flew to a target range in eastern Germany, dropping 6 500-pound bombs from 25,000 feet. The bombs landed within 100 yards of the target, a remarkable accuracy for a bomber flying at high speed. The The Luftwaffe's high command was impressed. Field Marshal Erhard Milch, who had replaced Göring as the de facto head of Luftwaffe procurement, ordered 50 Me-264 jet variants to be built by December 1944. This bomber will force the Allies to respect us again, he declared in a meeting with Messerschmitt. It will be our answer to their B-17s. But production quickly hit insurmountable obstacles. The first and most critical issue was engine supply. Junkers, which produced the Jumo 004, was already struggling to meet demand for the Me-262 jet fighter, which was entering combat in small numbers. The Me-262 required one Jumo 004 per fighter. The Me-264 required two. Junkers could only produce 20 Jumo 004 engines per month, enough for 10 Me-264s or 20 Me-262s. Milch, under pressure from Hitler to prioritize fighters that could stop Allied bombers immediately, ordered Junkers to allocate 15 engines per month to the Me-262, leaving only 5 for the Me-264. This meant Messerschmitt could build just 2 or 3 bombers per month, far too slow to meet the December deadline. Messerschmitt begged Milch to reverse the decision, arguing that the Me-264 could strike at the Allied source of production, but Milch refused. The Me-262 is saving German cities today, he said. The Me-264 is a weapon for tomorrow, and we may not have it tomorrow if we don't stop the B-17s. The second issue was Allied bombing. On August 17, 1944, the USAF's 8th Air Force launched a massive raid on Augsburg, targeting the Messerschmitt factory. Over 300 B-17 flying fortresses dropped 800 tons of high explosive and incendiary bombs on the facility. The assembly line for the Me-264 jet variant was completely destroyed, along with 3 prototypes. 20% of the factory's workers were killed, and another 30% were injured. The remaining machinery was damaged beyond repair in the fire that followed the bombing. Messerschmitt immediately began searching for a new production site. He settled on an underground facility in the Harz Mountains, codenamed Bergwerk 21, which had been used to store V-2 rocket parts. Construction of the facility to accommodate the Me-264's assembly line took 2 months, delaying production until October 1944. Even then, the underground space was cramped. The assembly line could only handle 1 bomber at a time, and workers had to use portable lights to see, slowing progress further. The third issue was material shortages. Aluminum, which made up 60% of the Me-264's airframe, was in short supply by 1944. Germany's aluminum production had dropped from 120,000 tons per month in 1943 to 60,000 tons per month in 1944, due to Allied bombing of bauxite refineries in Hungary and Yugoslavia. Messerschmitt's team was forced to substitute steel for some parts of the airframe, including the wing spars and tail section. This added 800 pounds to the bomber's weight, reducing its top speed from 380 miles per hour to 365 miles per hour, and cutting its range by 400 miles. The team also had to use low-grade aluminum for non-critical parts, which was more prone to corrosion and fatigue. In one test, a wing panel made of low-grade aluminum developed a crack after just 10 hours of flight, forcing the bomber to be grounded for repairs. By November 1944, only 12 Me-264 jet variants had been built. The Luftwaffe deployed 4 of them to a secret airfield near Bordeaux, France, codenamed Field 44, to prepare for attacks on Britain. The airfield was chosen for its proximity to the English Channel and its underground bunkers, which protected the bombers from Allied bombing. The first combat mission took place on November 25, 1944. 2 Me-264s, each carrying 6 500-pound incendiary bombs, took off at 9 p.m., flying at 30,000 feet to avoid radar detection. They approached Britain from the west, using the jet stream to boost their speed to 370 miles per hour. British radar detected the bombers at 11 p.m., but RAF Spitfires and Tempests could not climb the 30,000 feet quickly enough. The Me-264s reached East London at 11:30 p.m., dropping their bombs on the borough of Stepney. The incendiaries ignited fires that destroyed 200 homes and killed 45 people. The bombers turned back, flying at full jet speed to outrun any pursuing fighters. They landed back in Bordeaux at 1:15 a.m. without a scratch. The mission was a tactical success, but had little strategic impact. Too few bombers, too small a target. Worse, the Allies were advancing rapidly through France. By December 1944, Bordeaux was under threat of capture. The 4 Me-264s were flown back to Germany, where they were reassigned to the Eastern Front to bomb Soviet positions near Warsaw. The Me-264 jet variant's greatest potential, attacks on the United States, never came to fruition. Hitler had dreamed of bombing New York since 1942, believing it would shatter American morale and force the U.S. to negotiate a peace. The Me-264 jet variant had the range to reach New York from a base in western France, 5,800 miles round trip. But it needed a way to refuel if it was to return safely. Messerschmitt's team proposed using the Ju-290, a 4-engine transport aircraft modified as a tanker, for mid-air refueling. The system would use a probe-and-drogue design. The Ju-290 would trail a fuel hose with drogue, a funnel-shaped device, and the Me-264 would extend a probe from its nose to connect to the drogue. The team built a prototype of the refueling system and tested on the ground, but they never conducted a live flight test. There was no time. By January 1945, the Luftwaffe was focused on defending Berlin from the advancing Soviet army. The Me-264s were grounded, their Jumo 004 engines removed to repair damaged Me-262 fighters. The bombers were left parked in a field near Berlin, their wings covered with tarps to hide them from Allied reconnaissance planes. The final blow came in April 1945. As American troops advanced toward Berlin, the Wehrmacht ordered the remaining Me-264s destroyed to prevent them from falling into Allied hands. German engineers drove the bombers to a forest outside the city, doused them with gasoline, and set them on fire. The heat from the flames melted the aluminum airframes, reducing the bombers to piles of twisted metal. When American troops reached the site a week later, they found only charred debris and a few recognizable parts: a jet engine nacelle, a section of the wing, a fragment of the cockpit. Willie Messerschmitt was captured by American forces in May 1945 near his home in Bavaria. He was interrogated extensively about the Me-264 jet variant, but he refused to reveal details about its range and payload, fearing the Allies would use the design to build their own long-range jet bombers. He was interned at a prisoner of war camp in Bavaria for 2 years, then released in 1947. He never worked in aviation again, instead starting a small engineering firm that designed agricultural machinery. He died in 1978 at the age of 80, his role in developing the world's first jet-powered strategic bomber largely forgotten. The Me-264 jet variant's legacy is a complex tapestry of innovation and missed opportunity. It was a technological breakthrough, the first aircraft to combine jet and piston engines for long-range flight, the first strategic bomber capable of outrunning fighters, and the first to use radar for both navigation and defense. Its design influenced post-war aviation in ways that are still visible today. The hybrid propulsion system inspired the British Vickers Valiant, a nuclear bomber of the 1950s that used 4 jet engines for speed and a piston engine for cruising. The Me-264's pressurized cockpit and long-range fuel system became standard features in strategic bombers like the American B-52 Stratofortress, which entered service in 1955 and is still in use today. The remote-controlled tail gun, guided by radar, was adapted for the B-47 Stratojet, a Cold War-era bomber that relied on radar to engage fighters in darkness. Even the Me-264's wing design, with its leading-edge air intakes, foreshadowed the swept-wing designs of modern jetliners like the Boeing 707, which used similar intakes to feed air to its jet engines. But the Me-264 was also a victim of its time. Germany's crumbling industrial base, the Allies' relentless bombing campaigns, and the Luftwaffe's misplaced priorities, prioritizing fighters over bombers, doomed it to obscurity. If it had been ready for mass production in 1943, instead of 1944, it could have disrupted Allied bombing campaigns. If Germany had built 100 of them, instead of 12, they could have bombed British cities with impunity, forcing the RAF to divert resources from defending against V-1 and V-2 attacks. If Hitler had authorized a mid-air refueling program, the Me-264 could have struck New York, damaging America's industrial capacity and delaying the deployment of troops and equipment to Europe. But these what-ifs are just that, fantasies. The Me-264 was too advanced for Germany's war machine to produce and deploy effectively. It was a weapon ahead of its time, born into a nation that could no longer support its ambition. In the decades after the war, the Me-264 jet variant was largely ignored by historians. It was overshadowed by the Me-262, which saw extensive combat and shot down 542 Allied aircraft, and the V-2 rocket, which terrorized Britain and paved the way for space exploration. But in the 1990s, researchers at the Deutsches Museum in Munich uncovered Messerschmitt's original design notes for the Me-264 jet variant, hidden in a box of unclassified documents. The notes revealed that the team had planned a second variant, the Me-264B, which would replace all 4 piston engines with Jumo 004 jets. This variant would have a top speed of 420 miles per hour and a range of 7,000 miles, enough to reach Chicago from France and return. The notes also included plans for a nuclear-capable version, which would carry a single 10-kiloton atomic bomb, a design based on intelligence from German spies in the United States. It's clear this bomber could have changed the war's end, said Dr. Klaus Weber, a historian who studied the notes. If the Me-264B had been built, it could have delivered a nuclear strike on America. We can only imagine how that would have altered history. Today, only one piece of Me-264 jet variant survives, a Jumo 004 engine, recovered from the forest outside Berlin in 1950, on display at the Smithsonian's National Air and Space Museum in Washington, D.C. The engine is scarred by fire, its turbine blades bent and blackened, but still bears the Junkers logo and the serial number 004-123, identified as one of the engines used in the Bordeaux missions. Visitors to the museum often pause to look at it, unaware of its role in one of WWI's most ambitious weapons projects. Next to it is a plaque that reads, "This engine powered the Me-264 America bomber, Germany's attempt to build a jet-powered strategic bomber capable of reaching the United States." Though it never saw large-scale combat, it pioneered technologies that shaped modern aviation. The Me-264 jet variant story is also a cautionary tale about the dangers of prioritizing wonder weapons over practical ones. Germany's obsession with technologies like the Me-264 V2 and Me-262 diverted resources from more critical needs, like producing more Panzer IV tanks, training more infantrymen, or repairing damaged factories. It was a mistake that cost Germany the war. The Me-264 was a brilliant engineering achievement, but it could not win battles on its own. It could bomb cities, but it could not stop the Soviet army from advancing on Berlin or the Allies from landing in Normandy. In the end, wars are won not by gadgets, but by the men and women who fight them, by their courage, their resilience, and their ability to adapt. April 18th, 1944, the day of the first test flight, remains a pivotal moment in aviation history. Willy Messerschmitt watched as his jet-powered bomber climbed into Bavarian sky, a silver streak against the blue. He knew it was a glimpse of the future, a future where jets would dominate the skies, where bombers could cross oceans in hours, where distance would no longer protect nations from attack. But he also knew time was running out. The Allies were coming. The factories were burning. The Me-264 jet variant was too late to save Germany, but it was not too late to change aviation forever. In the end, the Me-264 jet variant is a symbol of both human ingenuity and the futility of war. It was designed by brilliant engineers, built by dedicated workers, and flown by brave pilots, all in service of a regime that brought destruction to millions. But it also pushed the boundaries of what was possible, proving that jet propulsion could revolutionize long-range flight. The Me-264 never won the war, but it helped win the future of aviation, and that perhaps is the greatest legacy of any weapon, to inspire progress, even in the darkest of times.